Good morning, students. So today we'll discuss about cephalosporins. Okay, cephalosporins. So we have already discussed about penicillins and there's various types of penicillins and their structures. So cephalosporins are also beta-lactam antibiotics, but the main thing is that difference between penicillins and cephalosporins is in the structure. That is, in cephalosporins, beta-lactam nuclease is fused to a dihydrothiazine nuclease, and penicillins, the beta-lactam nuclease is fused to thiazolidine nuclease. So that is the main difference between penicillins and cephalosporins structurally. Then cephalosporin compounds were first isolated from the cultures of Cephalosporium acrimonium. The cephalosporin nucleus, that is 7-amino-cephalosporanic acid, was derived from cephalosporin C and proved to be analogous to the penicillin nucleus 6-amino-penicillinic acid. Then cephalosporin N has a penicillin-like structure and it's a derivative of 6-amino-penicillinic acid. And cephalosporin P, it's an acidic antibiotic which is steroidal in nature, and the structure is similar to fusidic acid salt, that is fusidine. Then cephalosporin C is a true cephalosporin and it's a derivative of 7-amino-cephalosporanic acid. Okay. So now we will see the structure of cephalosporins. So what is the structural difference between cephalosporins and penicillins? So in penicillin, beta-lactam ring is fused to thiazolidine nucleus, and cephalosporins, beta-lactam ring is fused to dihydrothiazine nucleus. Dihydrothiazine nucleus. So sulfur atom is present at first position and fifth position, and at the fifth position a nitrogen atom is there, and third position is substituted by different groups. Here it is designated as R1, and at the fourth position COH group is present, and as usual we have seventh position substitution with acyl amino side chain, and eighth position keto group is present. Moving on to the classification based on generation. First generation examples are cephalexin, cephadroxil, cephaloridin, cefazolin. Second generation we have cefiroxim, cefaclor, cefprozil. And third generation cephalosporins are ceftizoxim, cefpodoxim peroxetil, cefoperazone, ceftazidime. Fourth generation cefepime, cefpirone. And second type of classification is based on route of administration, like oral, parenteral and cephalosporin combinations. Examples for oral cephalosporins are cephalexin, cephadrin and cefaclor. Parenteral, cephalothin, cefotaxime, cefazidime. Cephalosporin combinations are cefoperazone with sulbactam, cefotaxime with sulbactam and ceftriaxone with sulbactam. Now we will discuss about the structures of cephalosporins. We have already seen the structure of cephalosporins, and in the structure two substitutions are possible. That is, at the third position R1 group is present, and at the acyl amino side chain R group is present. So based on the substitution, various cephalosporins are there. That is, first one is cephalexin and cephradine, cephadroxil. So all these in all these cases R1 group is CH3 and the R group is a little bit different, and in the first case cephalexin we have CH5CHNH2, and at the second in the second compound, that is in cephradine, instead of this phenyl group we have a diene, uh, and in third one cephadroxil we have a hydroxyl group at the para position. And in case of cephaloridin, the R group is thiophene, substituted thiophene group, and the substitution at the second position with CH2. And R1 group is a pyridine, substituted pyridine is present. Then second generation cephalosporins we have cefaclor and cefprozil. And in cefaclor, one chlorine is present at R1 position, that is third position, and acyl amino side chain is attached with a benzyl amino group. And cefprozil, we have para-hydroxy benzyl amino group, and R1 group is CH double bond CH3. Third generation cephalosporins. And third generation cephalosporins, if you examine the structures, we can see that all these contain amino-thiazole nucleus, amino-thiazoles. Okay, so at the second position, amino group is present in thiazole nucleus. Second position of the thiazole is substituted with NH2, and the fourth position is substituted with imino group, C double bond NOCH3. So these third generation cephalosporins are also known as oximino cephalosporins. Oximino, OXIMINO, oximino cephalosporins. So a peculiar feature of this type of cephalosporins is that they enhances the penetration of cephalosporins across the outer membrane of gram-negative bacteria, and they have increased affinity for transpeptidase enzymes. Okay, so third generation cephalosporins examples are cefotaxime, cefixime, ceftriaxone, ceftriaxone. So in all these cases, R1 group is a little bit different. See, in case of cefotaxime, the R1 group is CH2OCO-CH3, and in cefixime, R1 is CH double bond CH2, and ceftriaxone it is hydrogen, and in ceftriaxone it is a substituted 1,2,4 triazine nucleus. 1,2,4 triazine nucleus is present. Okay, and we have fourth generation. Fourth generation is they have better gram-negative activity, and beta-lactamase resistance, and mainly they exist as switcher ions. Moving on to the chemistry, we have already discussed the general structure. The hydrothiosin nucleus is present, beta-lactam ring is present, and acyl amino side chain is present. So this is 7-amino cephalosporanic acid. The structure consists of beta-lactam ring fused with dihydrothiosin ring, and the nomenclature of cephalosporin is more complex than penicillins because of the presence of a double bond in dihydrothiosin ring. Basic nucleus is made up of 7-amino cephalosporanic acid. The semi-synthetic modification of the basic 7-amino cephalosporanic acid nucleus has resulted from acylation of 7-amino group with different acids or nucleophile substitution or reduction of the acetoxy group. The semi-synthetic cephalosporins has got the following advantages over natural cephalosporins, that is, increased acid stability, better oral absorption, broad antimicrobial spectrum, increased activity against resistant microorganisms, decreased allergenicity, and increased tolerance. And the mechanism of action is just similar to that of penicillins, that is, they are bactericidal, and they inhibit the peptidoglycan layer synthesis. And actually these cephalosporins, they disturb the synthesis of peptidoglycan layer of bacterial cell walls. As you know, peptidoglycan is important for cell wall structure integrity, especially in gram-positive organisms, and the final transpeptidation step is inhibited uh, by cephalosporins. So the final transpeptidation step in the synthesis of peptidoglycan is facilitated by transpeptidases known as penicillin binding proteins. So our first structure is cephalexin. So its trade names are Cefbact, Keflex. So its uses include bacterial infections, for treating bacterial infections including otitis media, streptococcal, pharyngitis, bone and joint infections, pneumonia, cellulitis, and urinary tract infections. And it may be used to prevent bacterial endocarditis and can be used for the prevention of recurrent urinary tract infections. Another one is cefaclor. At the third position, chlorine is present, and acyl amino side chain is attached with benzyl amino group.
And the uses include treatment of septicemia, pneumonia, meningitis, biliary tract infections, peritonitis, and urinary tract infections. And next is cefotaxime. We have already seen the structure of cefotaxime. It comes under aminothiazoles, and it's an example for oxyminocephalosporin. So a substituted thiazole nucleus is present, and substitution at second position, that is with NH2 group, and the fourth position is substituted to oxymino group. And the uses. So cefotaxime is used for a variety of infections, including lower respiratory tract infections, genitourinary system infections, gynecological infections, bacteremia or septicemia, and intra-abdominal infections, bone and joint infections, and CNS infections. That's all about cephalosporins. Please watch the video describing the mechanism of cephalosporins. Thank you.